Hi everyone. In this unit we're going to be talking about different types of reactions. But first thing we need to know is how to balance equations and how to write them. Okay, so let's go over a couple of review things. You need to make sure you know your super and subscripts. Okay, so if I'm looking here at oxygen, my top left and my top right, my bottom left and my bottom right. Okay, so my top right is going to be the charge of my ion. My bottom right is going to be the number of atoms. My bottom left is going to be my atomic number, my number of protons. And my top left is going to be my mass number. Now, the one that is going to be key in today's lesson is the number of atoms. Okay, that's the one that we're going to look at the most. So if I'm looking at water, how many elements does water have? It has hydrogen and oxygen, so it has two elements. How many atoms? That's when you got to look at all of the subscripts. So we've got two hydrogens and one oxygen, so we have 3 atoms. So making sure that we understand those numbers and how many of each atom there are, that's really where balancing comes into play. Okay, if we were in math, if you remember, if I look at an equation like 4x plus 2 equals 10, this 4, we have a name for it on that variable of x. That's called our coefficient. Okay, and when we are balancing equations in chemistry, we are manipulating our coefficients in order to make our equations equal on the left and the right. All right, on chemical equations we have an arrow. So the arrow is going to be our equal sign. Okay, so an arrow is going to be our equals in our equations. Okay, and it's called yield. It yields, it produces. All right, we also have a left and a right. Okay, our left side of our equation are our reactants, and our right side are our products. Sometimes you have multiple products, sometimes you have one. Okay, just depends on what type of reaction you're dealing with. So let's look at the production of water. Hydrogen plus oxygen yields water. Now, if you remember, hydrogen and oxygen are diatomics, so they must be written with a 2. So H2 plus O2 yields H2O. All right. So what we need to do now is look at the left side and the right side of our equation, and that's going to be where our arrow is. Okay. On our left side, we have 2 hydrogen and 2 oxygen. On our right side, we have 2 hydrogen and 1 oxygen. And what we want to do is make both sides of the equation equal by adding atoms. Okay, so in order to make both sides of this equal, we need to add oxygen to the right. But here's the problem: you can't just add a half of a molecule. The only thing that I have to go with on my right side of my equation is water. So the only thing that I can add to the right side of my equation is I can add a second water molecule. Okay, and that will change how many oxygens I now have on the right side. So I have 2 oxygens now on the right. I have 2 oxygens on the left, but something changed. Now I have 4 hydrogens on the right and only 2 hydrogens on the left. So in order for me to fix that, well, now I need to add another hydrogen on the left, but I can't just add a hydrogen atom. I can only add the diatomic that I have in my equation. It would be like if you were making biscuits with flour and buttermilk, and all of a sudden you decided to add mushrooms into it. It'd be quite a strange biscuit. You can only add buttermilk or flour. If it gets a little too runny, you add some more flour. If it gets a little too thick, you add a little more buttermilk. But you're not just going to randomly throw something in there. We can't just randomly throw something in there that we don't have. So you can only add what you're given. Well, now it appears our equation has all the proper atoms. So I have 2 hydrogen molecules, I have 1 oxygen molecule, and 2 water molecules. So we will rewrite this with coefficients in front of these molecules. I have 2 hydrogen molecules, I have 1 oxygen molecule, and 2 water molecules. Now, you don't have to write ones. You never have to write the coefficient 1. So your final answer would be 2H2 plus O2 yields 2H2O. Okay, and that is a balanced equation. Let's do another example. Let's add magnesium plus oxygen. All right, magnesium is not diatomic, so you only have to write it Mg, plus oxygen, which is diatomic, you have to write O2. Now when you put these two things together, you have to use your ionic charges. Magnesium oxide, so magnesium oxide. Magnesium is a +2, oxygen is a -2, so I get Mg2O2, but you don't write the 2's because they cancel out. So actually you'll have MgO, okay? So now that we have our formulas, now we can balance. So on my left, I have 1 Mg. On my right, I have 1 Mg. That one's good. On my left, I have 2 oxygens. On my right, I have 1 oxygen. So in order for this to be equal, I need a whole magnesium oxide molecule. So I'm going to add that to my right side. Well, that changed my Mg, so now I need another Mg, and that appears to have balanced. So I have my I rewrite my equation, MgO, and I count up my molecules. I have 1, 2 Mgs. I have 1 O2, I have 1, 2 MgOs. But you don't ever have to write the ones. So my final answer is 2 Mg plus O2 yields 2 MgO. All right. And that about does it. Okay. Next class, we're going to continue balancing, but we're going to use word equations because you also need to know how to write all the correct formulas as well. Okay. Until then, work together, help each other, and make the world a better place. See ya.